Hi everyone, welcome to another video in this playlist looking at 10 key topics trying to get a grade C in our Edexcel GCSE. We've got the list in front of us there. This video is looking at the second thing on the list, angles, and particularly angles to do with straight lines at the moment. There'll be a later video when we look at angles inside polygons and also angles inside circles. So this one is typically looking at those associated with angles around straight lines, parallel lines, Z angles, F angles and the like. So let's have a look at a couple of key questions here. The first thing to remember with these questions, it's all about your spatial awareness and being able to see things that maybe aren't as obvious, and also not necessarily focusing on just the angle that's been asked for in the question. The other thing where you're going to pick up all the major marks in this question is the reasons, the working out, the explanations for your answer, rather than just being able to find it by kind of doing some mental calculations. So let's have a look at this question. We've got what looks like a reasonably complicated diagram. We've got points P, S and R and they're forming a triangle. We've also got point Q here joined up to point S that's splitting the shape into two portions. And we've got also this key notation here, which you need to know for your GCSE angles questions. And when lines are labelled with a line on them, that means that they're denoting that they're the same length. So lines with a single line crossing them, or sometimes it will be a double line crossing them, they mean same length. And that's really important when we look for things like isosceles triangles and equilateral triangles. While we're talking about it, and not because it's relevant to this question, if we've got lines in the diagram and they've got arrows on them, usually single, but sometimes we can have a double if we've got two pairs of them in a diagram, that means parallel. So that means lines that are always the same distance apart, okay? And that leads to a few very kind of special angles to look for. So let's have a look at this question. We've got angle here of 25 degrees, and part A is asking us to find the size of angle W here. What we need to look for using our spatial awareness skills is anything in this diagram where we can relate it to other pieces of information. And the first thing I would suggest you look for, and do this in your exam by all means, have a spin round of the paper, have a spin round of the question paper, see if you can find anything that kind of in a new orientation looks a bit more obvious. So I've turned it this way, and what you will probably now kind of see and go with a little light bulb coming on is, oh, we've got a triangle here. So there's a triangle between points P, S and Q, and not only have I got a triangle, but just like we were talking about a moment ago, these lines here tell me I've got an isosceles triangle. And in an isosceles triangle, the base angles, so by that I mean the angles at the ends of the lengths that are the same. So this is one of the lengths, and this is one of the lengths, and they meet here at angle kind of point Q. So at the end of them, we have angle W, which is actually what we've been asked to find, and we also have the angle here. They are equal. So let's spin that back around. My spatial awareness there has helped me spot that just by having a little play around with the exam, moving it around. So what I can say for part A is that the size of angle W is 25 degrees. And then all I need to do to explain my answer is to say that base angles of an isosceles triangle are equal. And it's important we say equal. Don't just say base angles, because the examiner won't know anything about the base angles, or they'll assume that you don't know. So base angles of an isosceles triangle are equal. Therefore, and I'm going to use the maths notation for therefore, those three dots, therefore, angle, and I want to talk about this angle here. So we don't just call it P, because this could be angle P or this could be angle P. So angle SPQ, angle SPQ is equal to angle W. And that would be a perfectly acceptable answer. Let's move on to B then. And B says, find the size of angle X. And here's where I tell my students kind of like my biggest hint or tip I think I can with angles. Don't focus on the angle that they're asking you for, but focus on trying to fill anything in the diagram that you can, and you'll probably find, a bit like doing a Sudoku puzzle, you will end up being able to find the angle that you've been after kind of through a process of elimination. So let's go back to the question. I know this is 25. I now know W is also 25 because that's what we found in part A. And if I finish off the piece of work that I was starting round there, I've got that triangle here between points P, S and Q, and if I know these two are 25, then I should be able to find this angle relatively easy because I know the three angles in a triangle always add up to 180. So 25 plus 25 is 50, 180 subtract 50, means this angle here is going to be 130 degrees. Now I move on and I kind of say to myself, well, what else can I find in this diagram? It may or may not be x, it may or may not help me to find x, but there must be things that I can apply in this diagram. And what I can see here, all along point Q here, is a straight line. And that straight line has been cut up into two pieces, and those two pieces together have to equal 180 degrees. That's one of our geometry facts that we should have learnt this year. So angles on a straight line add up to 180. So if this bit's 130, then this bit has to be 50. And then what you'll notice, again, thinking about spinning around the kind of diagram, having to play with the examination paper, seeing what we can find. If I orientate it this way round now, I've got another isosceles triangle here, dash here and dash here, which tells me this angle is going to be the same as this angle, because they're both the base angles of the isosceles triangle. And what I know, therefore, is that the two ones that are labelled as x, the one that I was after and the one that I've just said is the same size, plus the 50 degree one that I've just found are going to sum up to 180. So I can do 180 subtract the 50, which I found in this corner here. So 180 subtract 50 is going to be 130. And then that 130 is going to be shared equally between these two parts. So I can do 130 divided by 2. So that's going to tell me that angle x is 65 degrees. So x equals 65 degrees. Now, of course, comes all the marks by give a reason, explain how you got there. So I just need to talk through those three stages, really. How I found this angle, then how I found this angle, then how I used that information to find these angles as well. So the first thing I would say is, I'm going to label this really nice and clearly for the examiner so he knows exactly what I did and how I did it. I'm going to say, number one, this angle here, which I'm going to call PQS, so angle PQS equals 130 degrees because angles in a triangle total 180 degrees. Therefore, 180 subtract 25, which was from SPQ, so angle SPQ, and subtract 25 from the one we found earlier, PSQ or W, equals 130. So I've used my first kind of geometry fact there to identify how I found this angle. Then I'm going to say angle, and we're talking about this one now, so SQR, so angle SQR equals 50 degrees because angles on a straight line total 180, and then I need to say therefore 180 subtract 130, which is this one here, angle PQS, the one we just talked about, equals 50 degrees. So I've talked about how I found this one, I've talked about how I found this one, and now I can talk about how I found x, and that's just talking about angles in a triangle equal 180 degrees. Base angles, just like on part A here, base angles in an isosceles triangle are equal. Therefore, angle x is equal to this one here, QRS, angle QRS. Therefore, SQR, this one, the 50, 180 take away angle SQR equals 130. So 130 divided by 2 equals 65 degrees. And there's our answer there. So we've gone through each of the stages, worked it out, but more importantly we've explained it quite clearly and succinctly to the examiner. Let's have a quick look at the second question down here that we've kind of been writing next to. We're not going to go into a lot of detail around the explanations. I will say them, but then you need to kind of pause the video and think about how you would phrase these in the exam. We've got three angles to find, A, B and C. And you tend to find with this type of question in the GCSE that they kind of label them in alphabetical order because they expect you to find them in that order, and you probably need to find one before you can find the other. Not always. Now, we mentioned some time ago now the idea of these arrows and what they mean. And when we see arrows in the exam, that means they've got parallel lines, and there's some very special types of angle we're looking for in parallel lines. There's two types. The first ones form a Z shape, with the parallel lines. Now that might be a traditional looking Z, it might be a backwards looking Z, it might even be kind of like a really stretched out Z. But the point we're making with that Z shape is that the angles inside the corners that make the Z, so those two, or those two, or those two, are always equal in size. Unfortunately, you can't say as part of kind of like a geometry fact Z angles, so we have to kind of use the Z to find them, but we have to give them their correct name, and what we call Z angles is alternate angles. So we say alternate angles are equal. There's also another set of angles, not to confuse you too much here, that you find in parallel lines, again that are going to be equal in size, and this time we're talking about F angles. So again, it's the angles inside the corners that make the F, and that F could be a traditional looking F, it could be a backwards looking F, it could be an upside down looking F, it could be upside down and back to front, or it could even be kind of like a really awkwardly looking stretched out lying down F. Its orientation could change, but the point is it's been formed from parallel lines and the angles inside the corners are equal size. Again, like the Z was called alternate, our F angles are called corresponding, and they're equal as well. Corresponding angles are equal. So let's turn to our question and have a look at how we find A, B and C. Now the first thing I can see, and this is just going to come from good spatial awareness and practice, is that here, between point V, then coming down this line here, and then going across here, I've got a Z. So the angle inside here and the angle inside here are equal sizes. So I can now I can label this angle here as 64 degrees. How would I explain it when it says give reasons for your answer? I would say the angle here is alternate, because it's formed a Z, with the angle here. Now you're probably sat there going, well, why is that useful? Because I'm trying to find angle A. Well, this is what I was saying to you about a puzzle, trying to fill in angles even if you're not directly asked for them, because what I can now find is here, kind of going diagonally up the page there, I've got two angles forming a straight line. Straight line angles always total 180 degrees. So angle A is going to be 180 degrees, which is the total of the two. Subtract the 64, which I know on this side, so I've got an angle of 116 degrees. I'm not going to write out all the detail I just spoke about, but remember you'd need to in the exam to pick up full marks, not just the 1 mark for the correct answer. Let's now have a look at B. And this one's incredibly easy so long as you manage to spot it. And what you should have done here is spotted here, and I'm going over and over it in a light blue here to try and help you identify it. I've just got a triangle. So ignoring this line VW, ignoring this line XY, ignoring the fact that there's a C in here, ignoring the fact that the lines extend beyond, I've just got a triangle here, two angles that are known, one angle that's been asked for, and I know that angles in a triangle always add up to 180 degrees. So 180, subtract the 64 that I know for this angle here, subtract the 47 that I know for this angle here, is going to give me the value of B. So we've got 64 add 47, that's 111. 180 take away 111, that's going to be 69 degrees. Remember, you don't just leave it there in the exam, you also explain how you found that. Finally C, and we go back to this idea of our Z's and our F's, and what we can see here, or I hope you can see, but with a lot of practice it'll be better, is I've got an upside down F. So there is an upside down F, which means the angle inside the corner is the angle inside the corner, so that's going to be 47. And then, although these we're going to explain are corresponding angles and corresponding angles are equal, here I have another straight line, and a straight line adds up to 180, so 180 take away the 47 that I know here is going to leave me with angle C, so 180 take away 47, well, that's going to leave me with 133 degrees. Again, remember, please explain that quite clearly to the examiner. So there's how we found all our angles to do with straight lines. Good key question that always comes up on the GCSE, usually on the non-calculator paper. Remember, the key thing here is to make sure that you explain really clearly and really ordered how you got to the angle that you were asked for, so that the examiner can give you all the marks all the way through.